scientist at Capgemini for 2 years now, and they're calling me AI lead nowadays because a year and a half ago they started rebranding all the data science projects that we do as AI. And then I was sold as an AI expert. So then I had to live up to the expectations. I'm a behavioral scientist from a background. Meaning, next thing I know, I was reading up on what exactly is AI, and I'd like to take you on a little trip through history on what exactly was AI in the 50s, what is it now, what is it going to be, and show what it can be right now through a few cases that we've built over the last few years. I'd like to start by taking you back to 52, when Turing, yes, Alan Turing from the Turing test, made a chess algorithm. It was a mathematical function that could play chess. Input current state of the board, output your next move. It lost 2/3 of the time, but that didn't matter. What mattered was that it was a functional thing, mechanical, that could play chess. Well, actually not mechanical, because it was just a function that he computed by hand with pen and paper during the match. But it was a logical thing that could play chess, and that was cool. So mathematical science progressed fast in those days, and you got predictions about, yeah, in 10 years' time we'll have computers smarter than people, which actually led to Asimov from the 3 Laws of Robotics writing the book The Rest of the Robots, because he was complaining there's too much fiction being written right now about robots being evil and taking over the world. He disliked that, so he instead wrote a book from the robot's perspective. So slightly familiar, actually. Then in '74, the dreaded AI winter happened, the thing that Toledo mentioned in the past hours. There was a lot of high expectations that were not being met, and then funding got cut and the market crashed, both in the scientific field and in the business. The main bottleneck here was hardware, because we had great mathematical models, but we did not have the hardware to run them on at scale. Then in the 80s, we continued with expert systems. Anyone here expert systems in the 80s? XCOM? Yes, I see a few hands. Saving 10 million bucks a year. Then it turned out it takes about 2 years to make this gigantic rule-based recommendation model, and they're outdated after half a year, because Moore's law says hi, and the recommendation models you're building stuff for progresses faster than the models. So then Gibson wrote Neuromancer, the start of the Matrix trilogy, invented the word cyberspace as a collective hallucination experienced by millions daily. Gibson this in '84. Gibson described a world where everyone's connected through a network, and all businesses ran on these networks, all the banks run on these networks. Breaking into these networks would actually be one of the major forms of crime. Discusses the issues with giving state citizenships rights to AI. Forms the basis of the Matrix movie trilogy. And basically writes about everything we're screaming about nowadays, but he did that 34 years ago. I'm kind of a fanboy, I'm sorry. The point is, then we had a second AI winter in '87, because once again overblown high expectations, and suddenly all the rule-based systems that we're building, all the expert systems, are bottlenecked by the fact that you have to manually build every part of it. So writing software becomes a major bottleneck. Then, in '97, it happens. IBM Deep Blue beats world chess champion Kasparov in a 4-against-2 matchup. Now, if you told a guy in the 50s, computer that can beat world champions at chess, he'd say, that's smart. Then, in the 90s, exactly that happened. And what did we say? Do we now have AI, artificial intelligence? No, we took a step back and said, but it's not really intelligent. Because it can't drive, it can't recognize cats, it can't sing, it can't play Go. Meaning AI can be classified as little more than a function of the time that you live in, because it changes over time. What we classify as intelligent changes over time, depending on what the computer isn't doing yet. I'd like to mention here that AlphaGo won by making moves that no human had ever done before, because it wasn't trained on beating humans, it was trained on beating itself. And then it was a 6 matches, and the second one it won. Then the fifth, the human actually won by starting to play in ways that humans had never played before, which the computer in turn was not able to beat, which is a highly philosophical thing, really. Nowadays, what do we have nowadays? Well, first of all, we have IBM Watson beating World Jeopardy champions, which is a quiz game. That was 2011-12. How? By uploading the entirety of Wikipedia into work memory. So that's work memory the size of this room. So it could query the entirety of Wikipedia within a minute. I want to know how they did the cooling. IBM, please tell me how you did the cooling for that. And, well, it beat the world champions fair and square, to which one responded by, well, I, for one, welcome our new computer overlords. That was 2011. I'm still waiting for the computer overlords. So we have Facebook that open sourced their Detectron algorithm, not just for object classification, but for actual image classification, each and every pixel, which is amazing from a mathematical point of view. We have Sophia, who got a chatbot who got state citizenship rights from Saudi Arabia, even though in the 80s William Gibson predicted it would be Switzerland to give them rights because money. No, this is marketing. And then we had Google Duplex, Google Assistant, making barbershop appointments for you. Who did not see this? So suddenly it appears real damn close, then suddenly far away again because certain critics pointed out how fake the conversation actually was. And where are we now then? Where are we now? Who knows how? Good. I'd like to quote Tesla, who in the end of the 70s wrote, AI is whatever machines haven't done yet. And that's the only time-independent definition of AI that I can give you, because as soon as a robot is doing it, we stop calling it intelligent. Meaning building AI is a quest for the impossible because, you know, you discredit yourself the moment you achieve it. But in the meantime, it means we get to build cool stuff, and that's what matters. To me, anyway. So that was Tesla, and that's the most sensible thing that has been said since. Now, I'd like to take you through at least a few distinctions within the field of AI. First of all, we have the scientific field of emulating human thought and behavior, AI. Then we have machine learning, which is a set of computational techniques currently very popular within the generic field of AI. Then we have neural networks, which is one of many techniques within machine learning, and it's vaguely modeled after the human brains. Not exactly the same, but sort of, kind of. And then you have deep learning, which is a specific form of neural net with many hidden layers. So deep learning is neural networks, is machine learning, is artificial intelligence, but not the other way around. So AI is not automatically machine learning. It's from very broad to very specific. Next, perception versus performance. This thing looks smart. Pepper, humanoid. That thing, does it look smart? It's only the Atlas GPU that basically revolutionized machine learning in 2013. This is the NVIDIA graphics card that allowed us to run computations at scale, which led to deep learning amongst other things. But it doesn't look smart. Which of the two are you trying to sell? Something that looks smart or something that is smart? This is a big conflict within the market. Computing versus capacity. You can have great GPUs for computing power. You can have great decentralized Hadoop networks for big data storage. Those two are not the same. And usually your project focuses on one and not the other, and then suddenly you're out of balance when you want to do both. Data quality versus model quality. Your model is only going to be as good as the data used to train it, as a good colleague of mine once said. And we have really great models. We also have a lot of data, but if its quality is not up to snuff, then what can we do? Goal in itself versus mean to an end. I once was asked, can you build me a brain? The issues with that is, even if when I tried to build him a brain, is that you have overly high expectations that you will never be able to meet because the expectations are solely in the realm of fiction and not science. Reductive versus inductive models. Your machine learning model will only ever produce something that will never put out something that wasn't put in the first place. So there was this company that was selling pizzas, and that the ultimate pizza slogan, by feeding a model every pizza slogan they had ever had. How many unique slogans will that produce? It will never produce slogans that weren't using the words that it was fed in the first place. Inductive systems, on the other hand, we don't have that. But that is often expected of us when we say AI. Strong AI versus weak AI, in the end, is a very crucial part, in that strong AI, context agnostic AI that can act, think, talk, and do everything HAL did, is fiction. The only thing we have is narrow AI, which is faster, smarter than humans at a very specific task, and very useless outside of that specific task. Sure, you compare a lot of narrow AIs to do something more complicated, but the expectation that a narrow AI will suddenly start doing generic things, that's not going to happen. And a lot of the fears attached to AI are about strong AI, not weak AI, as I will show you in the next few examples. Now, so it is this, it's not that, but then what is real, Marijn? Well, let me show you. This is the first project I ever did over here at Capgemini, AI-assisted auditing, which was a large party that had to read a lot of unstructured documents. We had a big team, had to read those documents. They spent at least 5 to 50 minutes per document. There were a lot of burnouts. It was frustrating because the inflow of documents only kept increasing. They had a backlog of literally over 9,000. And we built a model that could process 5 of those documents in 5 seconds. How, you may ask? Well, quite simply, we used IBM stuff in the first phase, actually. We took texts, we annotated them, so we highlight different partitions of those texts. This is an auditor, this is a legal reference, this is a year, this is a verdict, and how those parts refer to one another. So an auditor has a verdict about another financial party. And this looks like more of the same, but this was actually the first output of our model ever, when we trained it on 2 banks and fed it the reports of a third, and it could correctly identify different passages within those texts, and even do the relationship model correct. Then, here it gets interesting. Okay, I can't read it, but whatever, I'll read it to you. This is an American bank report. These are all downloadable, it's open data. We trained the model on European bank reports, then just for fun, fed it an American bank report. And it correctly identified legal references, because at that point in time the model started figuring out it says in accordance with, it's probably legal, which is our proud daddy moment. Okay, so you can highlight text, now what? Well, you can do it at scale. Our demo was feeding 55 documents to the model, and within seconds it pointed out to 5 documents that were either incomplete or couldn't completely be classified. And the auditor could now focus on the tough cases, the complex cases for which they were actually trained and educated. And the computer took care of the rule, which is a major thing you see in the workforce nowadays, in that the computer handles the rule and the human manages the exception. Next case, night vision, which there's a lot of visual recognition APIs available nowadays, with a lot of standardized models for recognizing this and that and that. But what if you want to recognize something that's not in a standard model, say for security reasons? And what if you want to run that locally and not in the cloud, and you don't say, oh no cloud, then then we can't do it. No, we're data scientists. We're doing it anyway, left or right. And that's exactly what I told my team, and that's exactly what we did. So we built a model that can count the amount of people in the car and whether or not they have the sunscreen down. Because why not? And it ran on a USB stick with 7 frames per second. That one we're very proud of. And what does it look like? Well, like this. Yeah. If you pay careful attention, it will have trouble with the British car because people were sitting on the wrong side. which is also, once again, one of the major issues with neural nets, which tend to make generalized notions from data, which can become skewed when your data is skewed. But anyway, this was a concept demonstrator. This is visual recognition. This is YOLO. You only look once. It's all open source. You can download and do it yourself. Actually, I once did it myself. These are my cats. Can anyone see the issue with this picture?
No. Segmentation.
Segmentation, how so?
Well, where does the first cat stop and the second cat start?
Exactly. It cannot discern between the two cats. It can only say, here be cat. I'm very happy. The other half of the time, the audience points out that there's cats on the pillow as well, which is not the major issue here. So far, results are inconclusive. I have, as of yet, been unable to train a model that can discern between the two. Then again, I sometimes fail to do that myself. Something different. This is the car that Ron just mentioned. We have it upstairs. It was trained in a virtual 2D environment to not run into walls or people, but mainly walls. And it can drive for like a minute or two, then the battery stops. But it's a self-driving car, and it taught itself to drive. Yay! This I can actually just show you. Let's see if the screen still stays on. Guess not. No screen, no signal. Damn. How about now? Yay! So, this is actually a live demo. This is running right here, right now.
Hey, I'm Ida. How can I help?
Get me GDPR experts in France and Germany.
Can I help you any further on GDPR?
So, Ida is basically my baby. We've been developing her for the last half year. And I yell at it, get me experts. Okay. Now this one seems sympathetic. It's German. Clicking it. Where does it take me? It takes me to a list of persons in a PowerPoint inside a SharePoint. Okay. Okay, sure. So, yeah, and can you tell me a joke?
Have you heard the rumor going around about butter? Never mind, I shouldn't spread it.
Okay. An AI use case, please.
I found the results on GDPR in the category expert.
Yeah, so far so good. So what's happening on the back end over here is that I yell at my computer, which I often do. My voice goes to Google. Google Speech has one of the highest performance speech components on the market. Turns it into text. Then we send the text off to Microsoft, because Microsoft, in my personal opinion, has very great text analytics models. And it discerns stuff like intent expert, topic GDPR, metadata tags, France and Germany. Then we construct a query based on that information, which enters Elasticsearch, which browses internal Capgemini systems and returns those experts straight to me without going to either of the cloud components, meaning the user input goes to the cloud, the system information output does not. Security's real happy with me. Why are we using all these different components? Well, because we can. I'm not only going to use Google or only going to use Microsoft. No, we grab the highest performance bits to build something cool. And now we have a chatbot that I can yell at and look up stuff in PowerPoint, stuff on the intranet, browse the GDPR legislation on the European webpage, browse financial documents like in the very first use case, and tell me jokes because we hooked it up to the Bad Dad Joke API because we could. And on the back end, it's not live checking all those systems, it's scraping those systems and storing that in a server, and every week it updates, because otherwise we would be flatlining our internal systems when I start yelling at my computer. How does the scraper look? Well, basically like this. So that's a part RPA, Selenium, if some of you know it. This happens basically every Sunday. The bot visits the GDPR SharePoint and a lot of other pages and basically browses through them and downloads everything and analyzes everything at a per rule, per page level and stores that in Elasticsearch, which actually has a lot of machine learning and neural networks behind it, meaning the chatbot here is only a tiny interface to address an intelligent search system. Chatbot is a medium, not a goal in itself. Next, something completely different, but again car-related, an outlier detection system for lease cars. So this party has nice cute boxes in their lease cars, and when you drive around and you push the button, it says for business. And then it tracks your driving so you can get a refund. And once a year there's an audit to check if you didn't go to Disneyland and wrote it down for business. An entire team of auditors was occupied for 3 months, manually checking all 3,000 cars. In 3 weeks, we built an unsupervised machine learning model. Isolation forest worked best, I believe, to check for outlierness and basically rank all 3,000 cars based on how weird and odd their driving behavior is. At which point now, only the top 300 cases, rather than all 3,000 cases, need to be checked by the auditors. So that's 90% work reduction. Yeah, pretty good, pretty good. I can't delve too much into the weird stuff we found people driving to and back and writing it down on business, but believe me, it's weird. And this is a really, really nonsensical graph about the project, because we had to anonymize it. So what else are we doing? A lot of different things. We're predicting barn fires for the Dutch government. We are automating the input of reporting like CO2 emissions based on neural nets. We inspect all the different speech to text solutions on the market and test through word error rates which ones are actually the highest. We improve the retail forecasting for major shoes retailers in the Netherlands. We help the Dutch government predict crime, and we optimize the replenishment for major supermarkets that you might shop at every Friday or so. We do a lot of things, and then we continue to talk about AI. So let's do a little buzzword bingo here. When I say AI, am I talking about machine learning? Anyone? Yeah? Yeah? I think that was sort of like a yes. Are we talking about data science? Yeah, I see nodding heads. Yeah, wobble those heads. Are we talking about big data? There's a wobble. Yeah. Are we talking about automation? Yeah, again a wobble. And how about cloud? Anyone? Sideway wobble. Okay. Security. Yeah, of course, security is important. Are we talking about, what else are we talking about? Robots, IoT. Did anyone mention blockchain? So, to me, and this is like my personal opinion, behind this, we're talking about data. Machine learning uses data. Data science is concerned with data. Data aggregates to big data. It results in automation. It's stored in a cloud environment. There are risks for security. And what is blockchain other than a way to distribute your data? At least according to the Japanese guy it was. So a lot of this is about data and how to create value from it, because we have a lot of it, and not all of it is of good quality. But it is the fuel that we use nowadays. You're going to say something about blockchain, aren't you?
No, I want to ask you, can you define data?
Can we talk about that after this? Because that's
important for your I mean, whether I agree or not with you is depending on your definition.
from a level of 0. I'm talking about digital information, basically, be it at a 0-1 level or highly aggregated log files stored somewhere in a backend server. There's a lot of it, and a vast majority of the time we don't even know we have it. Half of these cases are about grabbing stuff that's already there and that companies already have and utilizing it in new ways to, well, make things better.
Okay, so it's factual data, it's logs, it's sensor data, that kind of stuff.
Yeah, and IoT fits in there somewhere as well. Sure, sure. So, lastly, a few trends, because I think I also have to start wrapping up again. Explainability. Explainability is a big issue in the current field of AI, more specifically machine learning, more specifically deep learning, because neural nets by themselves are quite explainable. I can't say exactly in which way this will develop in the future, mainly because of point 2, which is elaborating on model techniques. If you look at research nowadays, the biggest project worldwide, OpenAI, has only a fraction of the budget compared to, say, the Large Hadron Collider. And the vast majority of AI research is actually scattered across the globe on tiny research units who are often doing the same stuff in parallel, inventing the same stuff 5 different times, which is actually a big bottleneck for the progress in this field. There's an ethics paradigm shift, yeah?
They don't talk to each other.
No, they don't talk to each other.
Why not? You have the
Because everyone wants to, be the first and monetize it. Which is actually why it's really interesting to see how big an earth shift open source is becoming in this community. Google developed TensorFlow. They had 3 competitors making similar packages. But Google's got adopted. Why? Because they did not stick a price tag onto it, but made it open and free and available to everyone. And that's why the community adopted that. And that's why we are running TensorFlow in every competitor's cloud nowadays. So I'm also optimistic about that at the same time. When it comes to ethics, Asimov complained in the 60s about too much focus on poor humans, computers gonna kill us, and not that much has changed actually. I'm very curious to hear more talk about the robot's point of view, because if we're gonna use machine learning to teach it pain through repeated exposure, I'm pretty sure an argument could be made against it. Market shift, in turn, because in the past, we have seen hardware limits. 60s, AI winter. We have seen software limits. 80s, AI winter. And now we have legacy systems. We have lots of data, but the quality thereof is not always too great. So, like Toledo already said, you can hear AI winter is coming, but don't trust Sean Bean because he dies in every movie he plays in. I would rather say the AI effect is coming, and then I'm quoting Tesla again, saying AI is whatever machines haven't done yet. And as this market and this field develops, what we classify as AI will take steps back further and further. So in 10 years' time, we'll still be building AI, but it'll be something completely different. And the stuff I've built today, I'll just like, yeah, no, come on, that was just deep learning. Well, that's actually a very negative thought, damn it. Expectation management is the above all most important trend. Because when we say AI, we do not think of the science. We think of the Hollywood movie we saw last week. Which gives me a great excuse to visit the movies constantly. What do we do in practice? We create structure in unstructured data and thereby make data usable to do stuff, to create business value, to aid processes, to predict, to classify, to drive cars, help the moon landing, or recognize my cats. And that's all great, and that's all very positive. And how do we do it? Well, we do it in 6-week sprints up there in the Innovation Center most of the time. And it looks real cool, it sounds real cool, but it's actually this. And actually, I love doing this because in the end, you end up building something cool. And that achievement, that sense of achievement, once it finally does not throw an arrow in your face but runs, that is the best thing ever. Thank you.